Alright, hi everyone, welcome to this tutorial on the DHT11 and DHT22 temp and humidity sensors. This is a quick start guide, and so its intention is basically to take from buying these sensors to wiring them up to your Arduino, uploading code to your Arduino, and then actually getting temperature and humidity data back. We're not going to be doing any advanced projects with them or using that data. We're just showing you how to set it up and pull that data back. If you would like a video like that, go ahead and comment. I'll be more than happy to make one, and I'll also be more than happy to answer any of your questions. So I'm going to be using my Arduino Mega, but you can use any Arduino, and I'll be using a DHT22. So the first thing we should go over is what is the difference between a DHT22 and a DHT11, because this guide is going to be applicable to both. So the main difference, and I have both datasheets for the 11 and 22 open, is their technical specifications. So I'll pull our 22s up here, and then our 11s up here. And essentially what it breaks down to, and I won't go through every parameter, is one is more accurate and has wider ranges and the other is not. And so the 22 is slightly more expensive than the 11, and it has slightly better accuracies and ranges. So for instance, this relative humidity is 0 to 100 on the 22, whereas it's only 20 to 90% on the 11. And that is a reduction of 30% of your actual available sensing range for your relative humidity. So if humidity was really important to you, especially at the very low end or the very high end, you might be forced to go with the 22. So obviously every project has different applications. And so I will post in the description both data sheets, and you can go through and say, hey, how much accuracy and what range do I need to use on these? If they're a little vague for you, you can also search online. There's people who have written them up, neater than some of this stuff can be a little bit confusing. You can also ask me in the comments. I'm more than happy to interpret that for you. But you can see that, for instance, they have temperature accuracy over here on 11 for plus or minus 2. Sorry, we got to go back. And where is the temp accuracy on this? I believe it is 0.5. So accuracy, humidity, temperature is 0.5. And so that can be pretty big for someone who needs to do something more accurate. So I'm pretty much going to flop between both data sheets because besides the technical specifications, they're pretty much the same, and some have better pictures for what we're talking about depending on what the topic is. And so the first thing I'll show you is the DHT22. This is what it looks like. It has 4 pins, and that's going to be the same as our 11. It's smaller, it's usually blue, and it has 4 pins. If we go down to our pinouts, it'll tell us what those 4 pins do. And so for both devices, the third pin is not used. And so essentially we can ignore this. The first pin is going to be where our power goes in. The second pin is going to be what connects our data and physically transports temp and humidity data over to our Arduino. And the fourth one's going to be ground. So I think the DHT11 dock has a little bit better representation on the next thing we want to talk about, which is, the wiring diagram, and I have an even better one coming up, but the MCU here is essentially going to be our Arduino. This is our sensor. We obviously have our power and our ground, and then this data line. But what's this over here? We have a separate line that goes to our power that has a 5K resistor on it hooking up to data. So basically how this data protocol happens is it's one pin that does both sending and receiving for both devices. And so because of that, the digital signal needs to read either high or low, and you can see it describes what's being communicated with each bit. The problem is when we build these devices, especially if they're around a lot of other electronic devices, is there's interference that can happen in this signal path. And what could happen is that your Arduino senses a high or a low signal that didn't actually occur from your 22 and vice versa, or 11. And it basically causes a communications error. So what this resistor does is make sure that this data pin is always high, unless one of these is grounding the pin. If one of these decides to ground the pin, it'll flood right back down to 0. But if it's not at 0, it'll flood it right back up to 5 volts. And so it keeps our communication line between exactly 0 and 5 volts and nothing in between. And again, that electromagnetic interference can cause that in-between, which leads our Arduino and our sensors to get confused. And so that's basically to clear out and make sure our data line is proper and secure from any interference of outside forces, essentially. So with all that being said, what I would suggest you do, not mandatory, but is to get one of these set up. So this is a 22. They also make ones for 11s. I have both. You'll see them later on when we actually go and show the hands-on version of my project. But if you notice, there's only 3 pins on these and they're on a board. And so what these are is essentially someone has taken the 22 or the 11, solder it to a board, and taken out that useless 3rd pin and put the pin out to 3. So you don't even have to worry about the 4th one anymore. But what they've also done is gone ahead and added in that resistor for you. So it says 5K here. From what I've read online, there's really no such thing as a pure 5K resistor. What it really is a 4.7. And I took a magnifying glass to my devices and I saw that was true. So what they're using and what the text sheets say to use is a 4.7 or 5K resistor to pull that data pin up. Now, you can also use a 10K. Most things higher than that 4.7 will be fine as a pull-up resistor. So if you don't want to buy these boards, that's fine. They don't add that much cost. But if you can't find them or you don't want to use them, I'll be going through how to use it even without these boards, even though I will be using these boards. So just a note, and we'll move on. And so you can see the diagram has 4 pins. I've included it there. And so let's go through what we would do if we're using the boards or not. And very simply put, we'll take our power and ground and put them over to our breadboard rails. And we'll ship power out over to our power pin, which is number 1. We'll ship our ground out to our ground pin, which is number 4. We won't do anything on our 3rd pin. And again, if you have one of the boards, just ignore that. You'll only have 3 pins. And our center pin in the 3-board topology, or our second from the left, in this 4-pin topology is going to be our data pin. And we're going to connect that directly to pin 2. You can change that number in our code, but that's what the default is. Now, if you're not using the board, you need to include a resistor. And you can see that we're taking a resistor from the power line, putting it in line with our 2nd pin here, and hooking it up to data again to smooth out that signal. So that's pretty much everything. That's the difference between our 22 and our 11. It's accuracy and range. That's our boards, which have 3 pins and a pull-up resistor. And that's our 4-pin standard with our pull-up resistor that we have to add. So whichever one you decide to go for is fine. And we'll go ahead and show you physically what my board looks like. And then we'll go into code. Okay, so here's my actual setup that I'm going to be using. We have an Arduino Mega. You can use any Arduino as mentioned before. And we have a breadboard with my DHT22 on it. We also have a DHT11 off to the side so you guys can see what it looks like and see the size comparison. We have my Arduino Mega hooked into my computer via the USB port, which is providing communications to the software and power. But again, once the sketch is uploaded, you don't need to provide that. You only need power. So any of the power options on the Arduino will do. Going over the wiring real quick, let's start with the board and how it gets brought over. So we have this red wire, which comes from 5 volts on the board and gets brought over to the power rail on the breadboard. We have the black wire, which provides ground and is brought over to the ground rail on the breadboard. And then we have this blue wire, which is on pin 2 and brings over a port for the data communications for the DHT22. So if I move these 2 objects back here and we can take a little closer look at the breadboard, we can see starting on the wiring on the back, we have our first gray little jumper wire that brings the negative terminal for the DHT22 over to the negative rail, and obviously the black wire brings it over to the Arduino. The next wire is the center wire, which gets jumped out real quick with this yellow wire, and then brought over by the blue wire to pin 2, and that's going to be our data in and out for the device. And finally, we have a gray wire that gets jumped over to our positive, or our 5-volt power line, and that's brought over by the red wire over to the Arduino. Now, we talked before about if you didn't have one of these style DHTs where it's hooked up to a mini board and they took off the 4th pin and they also added a pull-up resistor for you, you're going to need to do that. So the first thing I'd say is you're going to see a device that looks like one of these, but it doesn't have a board on the back and it has 4 pins on it. Now, I've shown the schematics before, so you should know which pin is the dud or not in use pin, and you can just ignore that and go ahead and wire just like this with that 4th pin excluded and it should work. But we also mentioned that these come with a built-in pull-up resistor. So where would you put that on in this topology? Well, it has to go on the data line, as we mentioned before, and for this particular breadboarding, it would be right here. So this same line where the blue and the yellow wire connect, you would put a pull-up resistor between this and the positive rail. So we discussed before what resistors could be used and what these most likely use and stuff like that. So that's where that would go. So now that we've discussed that, let's go ahead and go back to the software and see this thing in action and get it all set up. Okay, so now I'm in my Arduino IDE. If you don't know how to install the IDE or set it up, there's plenty of tutorials online for you. But getting started here, we're going to go to our tools, and we're just going to make sure the board is connected. So I've selected my proper board. You can select your board under this section, and then we're going to go to port and just make sure that it's recognizing my Arduino and that it's connected. So now that that's all good, we're going to go to Manage Libraries, and what we're going to be doing here is importing a library from Adafruit Industries. So what a library is, if you're not aware, is code that someone else has written that you're importing into your project and that you can lean on and leverage to do a lot of heavy lifting for things that maybe you don't want to write yourself or would take too much time, stuff like that. And so they've gone ahead and written code to interact and extract the data from the sensor and also expose it as different variables. And those variables we can call in our own programs to get that data out. And so it's a very powerful way to quickly get something up and running. So you can see that if we type in DHT and scroll down, we have the DHT sensor library by Adafruit, and I've installed the latest version, and that's what you want to do. So after installing it, we're not going to start off with writing our custom code right away. We want to see how to even interact with this device. So what I would recommend, and what I'd recommend with any library that has this option, is if they have example sketches, and in this case, if we go to File Examples, you'll see the DHT sensor library. And if we click on the first sketch, DHT Unified Sensor, they've gone ahead and created a whole example sketch of how to use it. And so once we kind of understand how this works, we can go ahead and create our own sketches and cut and paste different implementations from this sketch and have it working in our own. And you'll be doing this a lot, this type of concept a lot with different Arduino projects. So I want to go ahead and upload the sketch real quick and just get it running and show you guys. But the only thing you really need to do before this works for you is just to go down to this section and make sure you have the right DHT selected. So what happens is we can go ahead and uncomment something with 2 double slashes. I am using a DHT22, but if I wasn't and I was using an 11, I could go ahead and backspace and uncomment that. And now the code and the library knows that you want to use the configuration that's meant for an 11. We're using a 22 in this case on my Arduino Mega, so we're going to go ahead and uncomment the 22 and go ahead and hit upload. So it's going to compile this down to machine code and then go ahead and upload it. And it's done uploading. And we can see the output here on our serial monitor. So we can see a bunch of information about our different sensors printed out. And then we went ahead and are starting to print out our temp and humidity. So let's look at the code real quick. I don't have time to go over everything in a quick start guide, but if you want me to go in more depth or you have questions, put them in the comments, and if there's enough, I will either respond there or I'll make another video and go more in depth on these sensors and maybe do another project with them. So first, going down to void setup, which runs once every time the sketch is started, you can see that printout we saw on the serial monitor. This is basically creating a sensor object that is reading our sensor, and it has all these different variables underneath it. And you can see all those different names, versions, max values, resolutions that we saw printed out at the top of our communications port. If it allows me to go up high enough, there we go, is being printed out right here. The thing you're probably interested in is this void loop. This is what keeps looping around, running and running and running. And it has 2 sections, temperature and humidity. Each has an if and an else statement. Basically, if means if this is true, do this, and if not, do this. And the if statement is basically an error handler. So if there's an error, it's going to print out error reading temperature instead of trying to attempt to read the temperature. So that's good to have in there, and I'd recommend you import that type of topology or example into your own sketches so that you have error handling in them. The next thing it's going to do is just do some semantic formatting where it's going to print out temperature and the symbol, and within the middle being this event.temperature or this event.relative humidity, and that is going to paste out onto our screen. Now, one thing I will show you before we finish up here is, what if I wanted this in Fahrenheit? Now, some libraries and some sketches, there's a variable you can switch, much like we switched our DHT variable, to switch it to Fahrenheit or Celsius. I don't see that in here, so I'll show you just a quick and dirty way of doing that. So event.temperature is, in fact, the number that is getting printed out to the screen. So what we can do is, first off, just change this little string value to F, so it's the right, letter, and we can do the conversion from Celsius to Fahrenheit like we would do, with a calculator. So the conversion is simply 1.8 times the number and then add 32. So if we put parentheses and then do an asterisk, which in Arduino IDE is multiplication, we add a 1.8, and then we, outside the parentheses, so it gets added after the multiplication of 32, and re-upload our sketch. Done uploading. You can see the printout happened again from our void loop, and then I can confirm that is the temperature in this room, and probably the relative humidity. So there we go. And again, I think we talked in the beginning section about accuracies and stuff like that and calibrations, but you could also add a calibration here. If you realized that your sensor was off by a few degrees, this would be the place to subtract it. If you realized for whatever reason the calibration for your humidity is off by X amount of degrees, you could simply subtract it here. And that's how you would do that. So now you're free to go ahead and take this sketch, and as long as you have your includes and your defines and everything like that, all these little print lines, you can delete and basically just add and subtract what you need to your own custom sketch. And you can use these event.temperatures and these event.relative humidities as a way to import that data into whatever logic you're trying to develop. So that's pretty much it. Again, if you want me to go over any other sensors, any other Arduino stuffs, any other projects, go ahead and comment that. I'd love to look into that and do that for you. And if you have any questions on this particular project, just let me know. So thank you guys for watching, and I appreciate your time.